It says to estimate the mean score, mu, of those who took the medical college admission test on your campus, you will obtain the scores of an SRS of students. For published information, you know that the scores are approximately normal with a standard deviation of 6.2. So we have information about population, but we don't have mean. We have sigma, which is 6.2. It says you want to sample mean X bar to estimate mu with an error of no more than 1 point in either direction. So margin of error is 1. So plus minus 1, which is 1. It says what is standard deviation X bar must X bar have? So what is the standard deviation of X bar? Sigma over the square root of n, right? So as I said, we want to find sigma over square root of n. Okay, I have margin of error. I have this sigma. I know the formula for margin of error is z star sigma over square root of n, right? So I want this part, correct? Okay, to be able to find this one, I need to know z star, correct? Because I already know margin of error is 1. So I didn't use sigma equals 6.2 because I want the whole thing, this one, okay? So, how I can find z star? It says, what is standard deviation X bar must X bar have so that 99.7% of all the samples give an X bar within margin of error 1, right? If you remember from rule 68, 95, 99.7, we know that this one includes 68% of population, correct? And these two numbers are in a margin of error of 1 sigma on both sides, right? That was 68. Then we have 95%. And for this one, sigma is between 2 sigma minus 2 sigma and plus 2 sigma, correct? Then the last one is the one they are talking about, 99.7%, right? Within what? How many sigma? Negative 3 sigma was here and plus 3 sigma, correct? You can take this as a z star instead of going to table C and find the value of z star. If you know rule 68, 95, 99.7 and they gave you, they ask you for either of these. For this one, z star will be 1. For this one, z star is 2. for this one, Z star is 3 because it says 1 sigma, 1 sigma, 2 sigma, 2 sigma, and this is Z star sigma. So now I know what is Z star. Z star is 3 because we are talking about 99.7%, right? So I have this one, so I will rewrite this. Margin of error equal to Z star sigma over square root of n. For margin of error I have 1. For Z star I have 3 sigma over square root of n. So now what is sigma over square root of n? 1 over 3, right? Divide both sides by 3, correct? So what is that? Sigma over square root of n is 1 over 3. Do you have any question? So, it said, again, what a standard deviation must X bar have? We know the standard deviation of X bar is sigma over square root of n, right? So in a formula for margin of error, we keep this because we know we want this. So this one is separated. We need margin of error in this formula. We need Z star in this formula, correct? Z star in this formula comes from rule 68, 95, 99.7 because they asked us 99.7% of all the samples. So the Z star will be that number this much margin of error sigma, this much margin of error sigma, this much margin of error sigma. So 1, 2, 3 here will be Z star for us. So for 99.7% rule, Z star is 3. So we replace it here. And then they are talking about the margin of error of 1 point, correct? So we had this, replace this one. Sigma over square root of n will be 1 over 3, which is a standard deviation of X bar. So this is the standard deviation of X bar. Do you have any question? No?
Alright, so it's like another, it's like just the next chapter is finding standard deviation of X.
Next chapter?
Yeah, no, is this the chapter or just the...
This question is actually kind of mixture of chapter 15 and 16.
Yeah.
Like sampling distribution and confidence interval. So you needed both knowledge of these two chapters. So the next question says, how large an SRS do you need? Means what is the sample size, correct? What is the sample size? In order to reduce the standard deviation of X bar to the value you found. So value we found for the standard deviation of X bar is 1 over 3, correct? So for part B, we start with sigma over square root of n equal 1 over 3. Correct? This is the standard deviation they talk about. They found this. Then they are saying, what is this sample size should be, what this should be, in order to have 1 over 3 as a standard deviation for X bar. So, if we want to find this, we should have a sigma here. So what is sigma here? Exactly. So you will replace 6.2 for sigma from here. From the main part of question was talking about 6.2. So 1/3. So just with a kind of rearrange everything, you will have a square root of n equal to, this goes here, 3 multiplies to 6.2. Am I right? So what is the square root of n? Oh, actually, you know what? Let's do this. Because we want sample size, we should square both sides, correct? 3 multiplies 6.2 power 2. So now you can calculate everything. Yeah, they talked about margin of error in this question too. They said 1 point. So what you found for sample size? 65 point something or what? Oh, actually it's 18.6 power 2. 3, 4,
9.
okay, so what is the sample size? 3, 4, 6. If you remember last time, I said for sample size, if the number after decimal is small, the number is big, whatever it is, you have to round it up, correct? Just for sample size. So we need sample of size 346 in order to have a standard deviation of 1/3 for x bar. Do you have any question? So in your homework also for chapter 16, whenever they are asking you to follow the rule 68, 95, 99.7, you should use Z star from here, not from table C. If you want to actually find from table C, I mean you don't have it, but if you want to follow some method that I'm going to now talk about, you will find, for example, for this one, you will find 1.96 something like that. You know, this one is not that kind of precise or, exactly, correct. But if they are asking you to find using this rule, you just use this sigma, and kind of that is actually easier for you rather than calculating this stuff. So, okay, now there is this question. Actually, we have a question from previous section. What was that? We had 3 of them, right? Okay, so these are the questions we solved before, right? It says a simple random sample of 20 cars in the drive-thru of a popular fast food restaurant had an average bill of 18.21 per car. Suppose the distribution of drive-thru bill is distributed normally with a standard deviation sigma of 5.89. What is the critical value V star if the confidence level was changed to 94%? So if you look at the table C, you will not see any confidence level of 94%. For the next question, also 99.7, you don't see. Actually, if I was asking you for the next question, I was asking you for this one. If I was asking you to use that rule, you could easily use Z star equal 3, right? But when you are not asking for that, you should know how to solve to find the C star. Okay. Okay, so let me write down all the information we have for this question. It says X has a normal distribution actually, let me write it down the way I wrote down for chapter 16. Okay, X bar is 18.21, sigma is 5.89, and do we have anything? Oh, N is 20, right? C is 94%. We want to know Z star for this C. Okay. So the C, probability C, is the area in between these two. This one is symmetric to this part. And we had this picture in PDF. This one is symmetric to this one. This place here gives us the Z star. And if this is symmetric, you know that whatever Z we have on this side, we will have exact same Z on the other side, but the sign is just different, okay? These are all negative, these are all positive. So let's write down this one is negative Z star, correct? Because this one is positive. And this is C% probability. So all the area between these two lines is C% probability. So I want this C to be 94%, correct? And if you remember, the area under this was showing in table Z with a decimal of, for example, 0.9400, right? Like, we could write it down 0.9400. Then imagine we convert this to the percentage, so now we have 94%, correct? So the probability is this one, the percentage is this one, correct? Okay. So if I have 94% in middle of this distribution, And we know this one is symmetric to this one. So how much percent or what probability we have on this side? I mean area. And what percent here? 0.03. Correct? And then what about this one? 0.03 exactly. No, this is a probability, yeah. So 0.3 plus 0.3 becomes 0.06, right? So 0.06 plus this 0.94, totally 100. 1. Correct? Okay. So now, if I want to find any z on this axis, we had this kind of question before in chapter 3. The last question of the last part of every question I gave you was something like this. From probability we reached z star. Do you remember? We reached z value. Do you remember? From probability we could reach z. So now I want to find this z. I mean, it doesn't matter either this one or this one, but let's start with this one because this is a positive number. Z. So if I want to find this z, I should know what is the area to the left side of this z, right? So all the area from here to the end of this distribution will be 97. Okay? So now, I want to find a z for this area. Okay? Table A. This is a positive z, right? So I'm looking for area of 0.97, correct? 0.97. And okay, I see 97 here. But let's find something more close to 0.97. This one? This one? 1.8? So we chose 0.9699, correct? So I will write down approximately we found 0.9699. Am I right? We found this one, correct? And then z for this one is 1.88. And this is the z star we are looking for. Correct? So here there was a z, and this z is 1.88, and area to the left side of this z is 97% almost, correct? So we found the z. So this is the z star for C% confidence interval. So all the aim was to find a z star for 94% confidence interval, correct? So first we started with 94% in the middle of this distribution, correct? Then we said, okay, if we know this area is 94%, we know this one is symmetric to this one, so we found this area. So the total area on the left side of Z, all of them added up to 97% or 0.97. And then we found some probability so close to this. And for this probability, we know the Z value is 1.88, correct? And the location of Z is here. So this is the Z star for a confidence interval, for 94% confidence interval. So Z star equal 1.88 is the Z star for 94% confidence interval.
So what you did
So
is
that's
you just
what-
added that 0.03 and 4% to the 0.93.
Yes, to get 97, so all of these add up to the whole area on the left side of C, right? What's your question?
I was just a little confused because everything up to there, the z-score is 1.88, but it's with the 0.03, so it's 96.97 still. Or
So all the area was 97, right? Because we couldn't find the exact same thing, so we ended up choosing the closest area, correct? That's the reason. So this is similar to the last part of all questions I solved in chapter 3. The last part was always like from the probability we reach the z-value, if you remember. So this question is similar to those kind of questions. Okay, so now let's see. Solve this one. Try to solve this one. If you solve on your own, you will understand it better, and then you will understand if you have any question. Huh? What is that?
On the table, so if you pick the closest point, the closest 0.97 is value
96, 99.
and you just go to the left and you get the z. Because it has the z laid out.
Let me bring out the z table for you.
So first you find that probability.
And then for that probability, we find the z value.
Now the z is right there.
This was the closest.
So she has to find it especially with like one
Can you solve this one? Try your best. So what you will do, first, find the area in between this normal distribution and say, okay, this area is 97.5%, right? So now for this question, 97.5 is here, right? And then you will find this one, and then you will add this area to 97.5%, and then find the probability so close to whatever area you found. You will find the z star for that area on the left side.
Spark.
So have you paid attention for this part of question? I even didn't need sigma, I didn't
Yeah.
need x bar, none of them, right? None of them.
like a given level of something, I have a Z1 Z star for a given level. You're kind of trying to say Z star for the ones that aren't. For the ones that aren't. I'm trying to find out.
So,
$97.5%.
Which is a probability of 9.875. Knowing you, the more than 75 is actually a number of 2.24. So the Z is 2.24.
Because this table just show us area to the left side of C, right? So that's the reason. So that's why we have to add up everything on the left side of C.
Because you were like, why can't we just go 94% straight?
No, because we should have the total area on the left side.
Yeah.
What you found?
2.24.
2.24? Let's see. So now the Z star, what's that? C is 97.5%. So then this should be much bigger than previous one, like maybe here. So this all area in the middle is 97.5%, which is 0.9750, right? Correct? I want a Z star which is located here. What is this symmetric part? What is the area? This one. What is this area? 1.25%. 1.25%, which is 0.125. 0.
I think there's extra zero.
Yes, extra 0.
Or before that.
Before 1?
Yeah, between the decimal and the
Oh, okay. Here. Yeah, okay, that was 1.25%. Okay, so what is the next step?
Add 97.5 and 1.25, which is 98.75%.
plus 0.0125. You have too many zeros. Okay, so what is this? If you add this, 0.9875. 9875.
How about for this one?
Okay, so where's that? Okay. 9875. I see 9871 here. Oh, we have exactly same one. 2.24. So this Z is, for this one, Z is equal to 1.2 for which is the Z star. 2.24. Z star is 2.24 for 97.5% exact confidence. Okay? Shall we find 95% confidence interval? We already have the Z star. Let's find the Z star for 95% confidence interval. So our Z star should be 1.96, huh? So let's try it to see if we get the exact same thing or not. Okay? Do you understand what I'm doing?
Yes.
Even though we have the Z star, we want to just check to see if we can get the same. Do you have any question about this? So 95%. Yeah, I want to find 95%. Even though we have it, let's find it to see if we are expert now.
Yeah, it is 1.96.
You are expert already. So 95% here, right? 95%, which is 0.9500, right? I want this Z star here. So this area, 2.5. This area, 2.5%. 0.25. Am I right? Or 0.025? 0.025. Okay. Is that correct now? 0.95 plus 0.0250 is 0.9750. What is the Z star?
1.96.
1.96. So as you see, this one is the same. Any question? No? So you understood this, right? Okay, so this will be the last question in chapter 16. So let's write this down. It says an article in the Journal of the American Medical Association examined body temperatures of male and females. The mean explore of body temperature of females, 65 female subjects who participated in this study was 98.7 degrees Fahrenheit. Suppose it's known that the temperature is distributed normally with a standard deviation sigma of 0.72. Answer all these questions. Okay, so you will have 10 to 15 minutes to figure this out. Okay?
The whole thing? From A
Yes,
through D?
everything. Now you should know, huh? Actually, 92%. Let me see. I need to change one thing. Okay, everything is good. Everything is good. Anything wrong?
I'm just trying to see how it affect the population. Because it already gives us the confidence and everything. Oh, when we did it. One question is this. I'm just wondering how we use that to find the population.
It says give a 95% confidence interval for mu. You know how to solve this, right?
Yeah, isn't it just that? Important.
It says just construct a 95% confidence interval. The second one,
I'm saying,
interpret that.
is it 95% what we just did? 95%.
Oh no, for constructing 95% confidence interval, part A, you are going to use that formula, top part. C% confidence interval for mu. It says construct a confidence interval. So what was the formula for confidence interval? X bar plus minus sigma over square root of n. No, sorry. C star multiplies sigma over square root of n. Right? So that is the formula for confidence interval. Replace all the numbers. You will find the confidence interval. Yes. So plus means upper bound, minus means lower bound, right? It's a boundary.
So it's X. Plus.
What happened?
Oh, no.
The lower boundary is x bar minus c star sigma over square root of n. The upper boundary is plus c star over square root of n.
Yeah.
So 95% z star, we just found it, right?
That's what I was asking you about.
Yeah, 1.96, right? Z star for 95% confidence interval is 1.96.
So another question, so say we've got a question like this on the test, and it doesn't give us the Z like it does in part A. Then we would find, then we have to do the 95 plus everything first, and then find the Z.
So definitely for part A and E, because part E is just explained. A and E, I will give you the Z star for any confidence interval, I'm asking for part A and E. So you will not have, any problem. There is just a table, from table, you can easily find Z star. But for part D, or maybe C, I will ask you to find the Z star.
So on the 95%, we wouldn't find the Z star.
No, because it's already in table C.
Okay.
Look at the table C top part.
Okay, so we just go here.
Yes. And also in exam, I will give you a small kind of table showing that what it meant.
I'm trying to find out on table C. I went to 95%, and then it's degrees of freedom.
So look at the confidence level.
Yeah.
You found 95, right? And you can go to the bottom of table. You will find Z star. Do you see that?
Okay, Z star. Okay.
Okay, are you done? It says, okay, so we have n equal to 65, x bar 98.4, a standard deviation 0.72, right? 95% confidence interval for mu is x bar plus and minus z star sigma over square root of n. X bar is 98.4 plus and minus. For C equal 95%, Z star is 1.960. Am I right? So, we have 19, yes, that's good. 1.960 multiplies to 0.72 divided by a square root of 65. So what is the margin of error? This one is margin of error, right? So what is margin of error? 1.75? 0.175. Then we have boundary 98.4 minus 0.175, then 98.4 plus 0.175. Am I right? Is this correct? So 98.4 minus this much standard deviation is, what is the lower boundary?
I don't know the last number either. It's 98.225.
225. And then what is this one? 98 point. Okay. Okay, so this is a temperature, right? Degree Fahrenheit. Am I right? It says, so the body temperature. So we are talking about body temperature. So the 95%. We are 95% confident that the body temperature for females fall between 98.225 and 98.575 Fahrenheit. Right? So this was part B, correct? Part C says, how many N we need? Sample size. If we want the margin of error to be 0.1, so previously margin of error was 0.175, right? This one is a smaller, 0.1. So we predict that the N sample size should be bigger, correct? Because margin of error is smaller here. Sigma didn't change, Z didn't change. So margin of error, sample size is equal to Z star sigma over the new margin of error power 2, 1.96, 0.72, 0.1, power 2 is, can you give me the final answer?
Final answer.
You want it rounded or?
Not round,
Or
so we can,
I got 1.9. I mean, no, but 199.1.
oh, this is good. Is this correct? So how many samples we need?
200
Exact. 200 females. So previously we were using 65 individuals and the margin of error was 0.175, right? So now we decreased the margin of error to 0.1, so the sample size increased to 200. Correct? What is the Z star for 98% confidence interval? Did you have it in table C or not?
It was these.
Part D, 98% confidence interval.
It wasn't tables.
It was in table, huh? You didn't have to calculate. It was 2.326. So the Z star is 2.326. Is that 326?
Yeah.
This one, 3, 2, 6.
Okay. So you didn't have to calculate, but the next one you have to calculate. So the next one says 92%, right? The last one, we have, let's say 92% here, 0.9200, and it's not that symmetric, but that's okay. So I want Z star here, right? So what is this area? 0.04, right?
Yes.
This one is also 0.04. The total area will be 0.96, correct? So what is the Z star or Z value for 0.96 from table? 1.75?
Wait, do we use the C table?
We didn't have 92%, so we are not using Z table, right? But to find the Z value, which table we should look at? We should look at table Z or table A, right? So from table A, this probability gives you this Z value. So the Z star is equal to 1.75 for 92% confidence interval. Do you have any question? Okay, so we are done with chapter 16, and next time we are going to start the last chapter. We have 3 more lectures to the final, or the good better part is to end of semester. Just 3 lectures.